SwayamPrabha. Digital India. Educated India.
Welcome to the next lecture of discussion on reverse engineering. The topic itself looks to be very interesting. You are trying to do engineering in a reverse fashion. So, what does it mean? That in engineering terms, we start from a point, go to a line, go to an edge, go to a surface, develop a product. Now, when we talk about reverse engineering, you have a product and you go back and you go to the final destination of getting a point. So, that is reverse engineering. In today's world, reverse engineering, there is lot of discussion going on whether it is legal, whether it is good or bad, but reverse engineering is must. If you want to understand the state of the art today for a product, for a process, for a design, so you have to do reverse engineering. And when you do reverse engineering, it should be used for professional growth. So, you will, once you do a reverse engineering of the product, you will find out what are all the flaws in the product. You would look for improvisation from the standard part whatever was available to you. For example, in QFD, we all quality function deployment, what we do is we try to see the state of the art, and looking at several state of the arts, then we try to fix our specification and move towards our specification. So, reverse engineering is part and parcel of product development. If you don't do reverse engineering, you will not understand where are you placed amongst your competitors. So, the content in this lecture is going to be reverse engineering, definition, importance, applications and what are the different processes, and 3D scanning, little bit on hardware introduction, and reverse engineering hardware which is on contact, non-contact and disruptive things we will see. What is definition for reverse engineering? It is very generic. So, the reverse engineering is a process of obtaining a geometry CAD model from 3D points acquired by scanning / digitizing existing part or a product. You look at a product, you try to take a photo of the product, or you try to replace that image photo which was from through a light, now through a laser. So, you try to get points of data, or they are called as a point cloud of data, they get it, and from that you try to reconstruct a CAD model, and this CAD model can be used for analysis and further development. Is a process of obtaining a geometry CAD model from 3D points acquired by scanning / digitizing of an existing part. Why is it important? Because we cannot start from a very beginning to develop a new product every time. So, you cannot start from beginning, that means to say you cannot reinvent the wheel. Whatever is already existing, pull it up and start developing on top of that towards your customization of your problem for a customer. Okay. So, every time we can't start from new. So, either you use what is available with you, a technology, or you try to see what else is the products available, understand the technology and try to take it into your product and develop it. We need to optimize the resource available in our hands and reduce the production time. So, this is very, very important. Reverse engineering plays an important role in reducing the product life cycle time. Okay. So, keeping in view of the customer's requirement, in such cases reverse engineering is an efficient approach to significantly reduce the product development cycle. And believe it, my friends, this reverse engineering, it should not be I try to take a product, copy the product and try to produce the same. That is not ethical. What you do is you try to get the data and try to improvise the data towards your customer. That means to say you make a customization of the data, that is accepted. Okay. So, impeller design. So, people try to take a reverse engineering of it, understand. So, what it does is you use a laser and this laser tries to hit, then it tries to reflect data. So, maybe you try to, this is laser, you try to have a recorder. The laser hits, it reflects, the recorder records and you start getting the data in their XYZ plane. Is reverse engineering legal? It is also often lawful to reverse engineer a product or process as long as it is obtained legitimately. If the product is patented, it does not necessarily need to be reverse engineered, as patents require a public disclosure of invention. It should be mentioned that just because a piece of product is patented, that does not mean the entire thing is patented. There may be parts that remain undisclosed. Okay. So, the fundamental use of reverse engineering is to get the feel of the product in terms of dimensional accuracy and performance. This helps in improvisation and to determine the flaw in the product. This is what I would be interested to teach you, saying that please note this point. You have reverse engineered a product, excellent, but try to improvise it and try to determine what is missing in it and make it customized towards a product. So, the justification of RE, the fundamental use of RE is to get the feel of the product in terms of dimensional accuracy. This will help in improvising and to determine the flaws in the product. In other words, reverse engineering process is itself is not concerned with creating a copy or changing the artifact in some way. It is only an analysis in order to deduce design features from the products with little or no additional knowledge about the procedure involved in their original production. Even when the product reverse engineered is that of a competitor, the goal may not be to copy them, but to perform competitor analysis. So, this is what I was trying to again and again insist, and this point I have repeated. So, when you see legal and justification, this tries to fit in. So, what are all the processes which are involved in reverse engineering? So, reverse engineering processes. So, first what you have is you have an object. This object can be small, it can be large. For example, it can be an artifact, it can be a car, rocket, it can be even a temple, a statue. Okay, it can be as large as a car, as big, as large as a car, rocket, temple in terms of a temple, mosque, statues, whatever it is. So, the object can be small, the object can be large. So, we take that object, then what we do is we try to scan the object. We try to scan the object. When scanning, what we do is we try to take the data points. See, first what we do is we try to take a complete object, then we try to section the object into several planes, and in each section we would try to look for XYZ data in that plane. Okay. So, once I get that XYZ data in one plane, so then I can start using it for reconstructing. So, scanning is something which is the next step, major step. The scanning can be done by two ways. It can be done by contact, it can be done by non-contact. It can be done by contact methods, it can be done by non-contact methods. Contact method means I can touch and try to record the data in the XYZ plane. Second thing, I need not touch. I use a laser reflection of the object, from there I try to take. So, scanning can be done contact, it can be done non-contact. So, then what we do is we try to take all the data. When you take contact or non-contact, what it will have the data of XYZ point in 3D. and from this you can also try to get a plain data. It will try to collect all the data. So, it is called as point cloud data. It collects all the point cloud data and then it tries to bridge. Whatever data we get here, it need not and it will not be perfect. So, you have to use several algorithms to remove the imperfections in the point cloud data. That is basically signal to noise ratio. You apply some filters, remove those noises, and then you try to work on particular patches. When you try to work on this particular patch, so then what happens? It will try to, you can remove it and then you can try to reconstruct a CAD model. So, from a CAD, moment a CAD is got, so you can try to go for CNC machine, you can go for inspection, you can also go for rapid prototyping. So, the CAD gives you lead for manufacturing. So, if you look at it, so this goes like this: physical model, it transformation of a physical model, then you try to digitize of a physical model, then you develop a CAD, update a model of CAD, then you develop a model, and then this is brought back to the physical model. So, this is a cycle which goes around. Okay. So, digitizing of object, that means to say data capturing, is a very important step, and this scanning of data and digitizing of scanning and then bridging of the data is very important, and lot of mathematics is involved. And interestingly, if you see, today you have many mobile phones which has two cameras. The logic for these two cameras is to get the depth information more clearly as in a plane. So, the difference in time is used here for trying to get more realistic data. So, the scanning technique and the scanning accuracy dictates the next process of point cloud data, and from the point cloud data you try to develop a CAD data. So, this portion of converting point cloud into CAD data, this is even today a hot area. There are few experts only who can work on this area of converting this point cloud data into a CAD data. So, this needs lot of expertise. So, the second thing, as I told, it is processing of measured data, then creation of CAD model, then you do prototyping. Why do you want to do prototyping? You want to reduce life cycle, product life cycle time. So, if you look at it, these are the processes which are involved. A is a wooden pattern which is made, and from there when we do that scanning, it can be contact or non-contact, you get a point cloud of data. Then you see that there is a lot of error in the point cloud of data. These errors are removed and what you get is a 3D data. From the 3D data, you can directly send it to a CNC machine, or you can directly send it to a RP machine, so that you try to get the same product manufactured. So, depending upon the time and the accuracy you spend here, the output will be very close to the input, whatever it is. So, the scanning, as I told you, there are two types of scanning. One is called as contact type, the other one is called as non-contact type. In contact type, we always use a coordinate measuring machine. CMM is nothing but coordinate measuring machine. So, coordinate measuring machine. So, this coordinate measuring machine is very slow in nature, and if you have a very soft material, something like a latex, rubber, okay, tissue. So, all these things, when you touch it, it has elastic deformation. So, the data what you get here may not be correct, will have some inaccuracies, correct answer, do not go glaringly, and the error what we talk about will be sub-micron error, sir. It is not in millimeters, please do understand that also. So, what is this coordinate measuring machine? I touch this probe onto the workpiece, and what I get is coordinate points x, y and z points. So, that is why it is called as coordinate measuring machine. Okay. The non-contact type, we can use laser or optics and CCD sensors to capture the data. So, this is a typical atomic force microscope working principle image. So, I have just put it as laser non-contact scanning just for your understanding. So, here is a probe. So, this probe, at the back side of the probe you put a reflecting material. So, the laser hits at the backside of the probe. So, moment the probe moves up and down, so this laser also moves up and down, and this is detected by a photodiode. This photodiode tries to move in left and right direction, and it will try to give you the voltage. Now, the feedback electronics is used to improve the voltage into linear displacement. You try to get the output. Okay. So, again here what you can get is a point data. So, from a point you convert it to a line, and several of these lines convert together to make a surface. So, that means to say with this technique you can get 1D, 2D and 3D. So, this is 1D, this is 2D and this is 3D. So, this is a surface data you get, fine. So, shiny surfaces and surface parallel to the light axis cannot be scanned accurately. This is a limitation of this process. Okay. However, this can be overcome by several techniques. So, we will see. So, in the 3D scanning process, for an ideal 3D scanning process, the scanning procedure has been divided into acquisition of data, alignment of data, mesh generation, post processing and simplification. These are the 5 steps which are involved in 3D scanning process. Acquisition, alignment, because you are trying to acquire, and suppose if it is not aligned in one particular plane, it is misaligned. So, alignment is a problem. Mesh generation, post processing and simplification are some of the major 5 steps involved in 3D scanning. Acquisition. Acquisition is the first fundamental step in which the acquired image is created in the software as a set of points. These points define a 3D representation of a part of the body that has been framed, and when hit by a light pattern generated by the projection. So, a light is trying to hit at a surface and it is trying to capture. So, for this reason it is advised to proceed with the acquisition of a wide part of the object first, post processing the acquisition of data, and missing part is in a following moment. Once a rough 3D construction has been obtained, the scanning can be improvised by adding more views that corresponds to some missing part. For example, you view the object from here, then you view the object from here, then you view the object from here. Okay. So, then what happens, you can reconstruct the image of the object in a very nice fashion, so that you get a 3D image. Alignment. Alignment is a work phase where it is possible to bring to the same reference system the range image acquired previously. Alignment is something very interesting. Suppose if I have an object placed in a plane, and suppose if the object is slightly deviated, so then what happens, there is a plane, reference plane, there is an error. So, whatever data you acquire and then you try to project it on the plane will have some error. So, it is always better to remove this error in the plane in the first position and then start acquiring data. Okay. Or you try to calibrate your camera first, understand the error in the camera and then start working on the image. So, that is what is alignment. Alignment is the work phase where it is possible to bring to the same reference system the range image acquired previously. The alignment can be done manual, the alignment can be done global. So, the process is manually helped by the identification of 3 corresponding points between the 2 acquisition are taken into an account. So, this is manual alignment, and global alignment is besides manual alignment that work with the identification of 3 corresponding points. Another alignment tool called as global alignment is also available. It is advised to run this command after having manual alignment all the range images. This way the alignment of each acquisition is optimized with respect to each other. Once you have made the point data, now the point data is assembled, and what you do is you try to do a mesh generation. Once a sufficient number of range images have been acquired and aligned in order to create a 3D model, as complete as possible, the next step is to triangulate the mesh. The mesh generation converts a set of 3D points, a range image, to a data constituted by a set of triangles. So now what has happened? Earlier you had data points, now these data points are connected into mesh, into several triangles. The mesh is first useful data that can be elaborated and exported in the available format. So the point cloud data is converted into a mesh data, then this mesh data is exported for other use. So you can see lot of meshes here, you can see lot of meshes here. Then comes the post processing. Post processing is every operation that involves the enhancement and finishing of the mesh. So the mesh, whatever you do, are nothing but facets. These facets are always having sharp edges. Okay, sharp edges. So in order to remove the sharp edges and make it smooth, so we always try to enhance and finish the mesh. It is possible to prepare a complete and a flawless 3D model ready for export. These operations should be chosen depending on the results to be acquired, and that can affect more or less a 3D model. Make manifolds. This involves solving the possible topological issues that can be attributed to the presence of a triangle edge shared by more than two facets is called manifolds. Deduction and repair. So what happens is, deduction means you might have a triangle, you might have another triangle like this, or you might have a triangle like this which pierces into the other triangle. So now these things are called as defects and repair. So you detect the defects and then you repair the intersection, solving some possible topological issues attribute to the triangles that intersect other triangles of a mesh surface. Fill holes, deduction, and all these things, if you start working on CAD, if you read through course, you will see that there is something called as Euler's formula. So in Euler's formula, what it does is, it checks for overhanging, it checks for number of holes, and then it tries to validate an object. Basically, the post processing is trying to validate the object. See, the meshes can be hanging here and there, but if it has to be completed and form a solid, so then you have to do all these things. Detection and fixing of missing parts on the mesh surface is filling holes. It automatically fills the missing data with a surface correspondence to the triangle that propagates the nearby shape and the texture information. So the final thing is simplification. Simplification, under this process are gathered all steps made on the mesh that to simplify the data, reduction of the noise, and mesh dissemination, reduction of a number of mesh triangles, because each mesh is going to operate is going to eat away a lot of space. So maintaining so much of meshes means it is going to store it is going to have a huge set of data in the server. So storing and editing becomes a problem. So in order to generalize and reduce the number of data points, it is reduction in the number of mesh triangles we do. This operation can be done forcing a tolerance that guarantee that the disseminated 3D model does not differ more than the value for an original model. It is done in order to have a more manageable file. That is what I was saying. When you talk about CAD, we talk about three things. One is how simple, thing is how easy to store, and how easy to edit. So the simplification is more towards that. Simple to store, simple to handle, easy to store, and easy to edit. It does not occupy a simple to handle means it does not occupy a huge space. Okay. So reverse engineering hardware and software. When we talk about reverse engineering hardware and software, RE hardware is used for RE data acquisition. There are three major technologies for RE data acquisition. One is contact, another one is non-contact, and the third one is destructive. Generally, we do not prefer for destructive because it is a costly episode. So we damage or we lose a part. Output of the RE data acquired are 2D cross-sectional image and point cloud that defines the geometry of an object. RE software transforms the RE data produced by RE hardware into a 3D geometry. The RE data processed chain can be one of the two types of 3D data. It can be a polygon data or it can be curves. If you have points and if you know to connect the points through a line, and if you can define a line, point, if you know to define a point, if you know to define a line, if you know to define a curve, then rest all is a piecemeal of whatever you have. Okay. Polygon models are commonly used in rapid prototyping, laser milling, 3D graphing, simulation and animation. When we talk about hardware, there are 4 different types of hardwares. So, one is called as the laser tracer. So, this is a system wherein which it can swing around this plane, and this can swing around this, and the height can be adjusted. So, this is a laser tracer wherein which you get the XYZ data. Okay. The next one is a total station. So, this is a total station. It is basically used by civil engineers to check the distance. Okay. Next is digital photogrammetry. So, it is taking a digital image and then taking a photo, converting into a digital image, from there trying to get data. And the last one is a portable CMM. See, in this portable CMM, it is pretty interesting. All the data references are given with respect to this plane, and if this plane is not aligned, so all the data whatever you get in XYZ plane are that data with this small error. So, this is why we said alignment is very important. Portable CMM is another thing wherein which you can take the CMM, go to any place, put it in any surface, make that surface as flat, and then you try to calibrate your CMM data points, and then you start measuring. So, the encoders over here, they try to take all the error, calibrate it, and then start taking measurements. So, the contact type, use sensing devices with mechanical arm, CMM and CNC machine to digitize a surface. Even a CNC machine can be used to digitize a surface, very easy. What you do is, you try to take steel or a metal, then you have a workpiece as metal. So, you try to make a connection between these two, and when it comes closer, when it touches, the resistance goes to infinity, and from there what you can do is you can start noting down the XYZ data points. So, this fellow can move step by step and it can move in XYZ plane. So, a CNC machine can be used as a coordinate measuring machine. The point to point sensing with touch trigger probe installed on a CMM or an articulated mechanical arm, that is what I said, portable arm, to gather coordinate points of a surface. The CMM provides the more accurate data, measured data compared to articulated arm, because CMM always they have a frame wherein which the frame is standard. Articulated arm, so the reference plane is a challenge, but due to lack of number of degrees, it cannot be used for digitizing complex surfaces, CMM. Analogous sensing with scanning probe installed on CMM or CNC machine. Scanning probes. The scanning probe provides a continuous deflection output that can be combined with the machine position to derive the location of the surface. Scanning probe. Scanning probe means a probe keeps, without touching, it keeps scribing on the surface. A scanning tunneling microscope, scanning probe. Okay, they are called as SPM, scanning probe microscopes. Okay, in this comes your scanning tunneling microscope, atomic force microscope. All these fellows are there. All these fellows are also can be thought of in reverse engineering. When you talk about a nanoscale and micro scale, if you want to measure the features, contact measurements is not possible. So, that means to the major contact, if the diameter is too large, it is not possible. Lasers are not possible, light is not possible. So, there we use contact with scanning probe microscopes. Okay. Point processing. So, import the hardware. So, importing the point cloud data, reducing the noise of the data. So, this is what is signal to noise ratio. You have to reduce the noise and increase the signal. So, you have amplifiers, you have filters, electronic filters today. So, this tries to do the job. Reduce the number of points. These tracks are performed using a range of predefined filters. Multiple scans are sometimes needed to ensure all the acquired points are scanned. So, you scribe it 2-3 times to make sure all the data points are got. A wide range of commercial softwares are available today. The output is clean, merged point cloud data set is the most convenient form of doing it. This is a point to point sensing system. This is a CNC CMM system. In the CNC CMM system, this is what is a probe, it touches, and here it is not electrified, so it is only a physical touch you try to measure, and it is a trigger probe is used you to get it done. So the other one is also the same. It has a frame wherein which the arm is used. So here arm is not used, a gantry is used. So the geometry is different, the structure is different, but the data whatever you get is a point data. So you can also have there are different types of the thing. What you have to note down is different probes. So this is called as a star probe. This is a long lengthy probe. This is a slender probe. Okay, you can have. So these are all probes which are attached to the CMM and you get the data. So here is a Roland, which is a machine wherein which it is used to scan and then mill. So for example, you can put a surface which you want to scan. So it scans the surface and then it executes the milling operation in a single machine. Okay. So scanning and milling machine used Roland active piezo sensor for 3D scanning. So scanning can happen here, and then the data is taken to it, and then that corresponding data is executed. This is nothing but an MDF, okay, which is a wood based material. So the accuracy of contact measurement, it is highly accurate, it is low cost. Our ability to measure deep slots, because suppose this is there, so this is called as, this is the depth. So here we call it as a high aspect ratio holes. Okay, high aspect ratio holes. So if you want to do high aspect ratio holes, then contact measurement is the only thing. Invisibility to color or transparency is removed from here. The next one is non-contact type method. Non-contact type method, here we use a 2D cross section image or a point cloud are captured projecting an energy source like light, sound or magnetic field. It can be light, it can be sound, it can be magnetic field, but predominantly what we work is using light. But there are acoustic based sensors which are available for measuring the surface. Okay. So magnetic field on the object. Then either the transmitted or the reflected image is absorbed, and the geometric data are calculated by triangulation method. Height is known, distance is known, or this distance is known. So you try to get the triangulation. This is a triangulation method. Next is time of flight. Time of flight is, you have an object here, the X-ray is thrown from here, the X-ray is collected here. So this is throw, this is catch. So this is the time of flight. What is the time required for a data from here to fall on the object, and from the object it reflects to this thing. So wave interference interferometer. So here what we do is we try to create an interference pattern, and that pattern is try to strike the surface, and the reflection is taken and counted, and several other image processing algorithms are used. The classification of non-contact RE hardware are based on the sensor technology or data acquisition technology. Non-contact methods. So I would like to draw the schematic diagram. So non-contact methods. So it can be on reflective, it can be on transmissive. Okay. Your CT and MRI are also non-contact techniques wherein which we try to get the data. So in reflective type, again you can have non-optical and then you can have optical. Okay. So non-optical, you can have microwave radar, which is used in defense application. Then you can also use sonar, which is used in the ships. In the optical way, you can have two classifications. One is called as active, the other one is called as passive. Okay. In passive, you can have shape from shading. Okay. Then you can have shape from stereo, you can have shape from focus, you can have shape from motion. Okay. When we talk about active, we talk about triangulation, we can talk about structured light, we can talk about Moyer effect, okay. We can have time of flight, and we can have laser, coherent laser. These are the classifications of hardware devices used in RE. Okay. This tries to talk about the complete gamut of things which are available. What is the advantage of non-contact type? No physical contact, fast digitization of sustainable volume, good accuracy and resolution for common applications, ability to detect color can be done, ability to scan highly detailed objects where mechanical touch is not possible. All these places we go for non-contact type coordinate measuring machine or non-contact techniques. The technique which is used in optical most common is triangulation. Most laser scanners use first straightforward geometric triangulation to determine the surface coordinates of an object. Triangulation is a method that employs location and angle between the light source and the photosensitive device, that is nothing but a CCD, to calculate coordinates. So, please understand, method that employs location and angle between the light source and photosensitive device. Okay, triangulation, angle theta. Okay. There are two variants of triangulation schemes using CCM, that is charged coupled device cameras, single and double CCD cameras. In single camera system, a device transmits a light spot onto the object at a defined angle. A CCD camera detects the position of the reflected point on the surface. In a double camera system, two CCD cameras are used. This is what is latest mobile phones use. The light projector is not involved in any measurement function and may consist of a moving light source or line, moving strip patterns or static patterns. So, this is triangulation. You can see laser coming out of this, trying to hit the object, and then it tries to reflect back, and here is a charge coupled device which is nothing but a CCD camera. Okay. So, this is the range with which the object moves, and this is the reference distance, and these are the target surfaces. Okay. This is a laser, this is an object, or this is a device inside which a laser diode is there and a CCD is there. So, from figure A, the high energy light source is focused on and projected at a specified angle theta onto the surface. The photo device senses the reflection from the illumination point of surface. The fixed base length is L. So, finally, if you look at it, you get through the formula of this, where Z, the geometric triangulation from the known angle theta, the focal length of the camera is F, the image coordination of the illuminated point is P, the fixed length is L, the illustration point Pi with respect to the camera coordinate system is given, where x is defined as L minus Z by tan theta. The measurement error of P and theta can be determined by these formulas. Okay. The next one is structured light. The structured light pattern is projected at a known angle on the surface of interest, and an image of the resulting pattern reflected by the structure is captured. Okay. The image is then analyzed to calculate the coordinates of the data points on the surface. The light pattern can be a single point, a sheet of light, or a strip of light in a complex manner. The most commonly used pattern is a sheet of light that is generated by fanning out of a light beam. So, then we try to get the XYZ data. So, the data acquire is very fast, color texture information is available, structured light does not use a laser. So, the maintenance is slightly economical. So, this is what are the different types of structured light: a single light strip, okay, then multiple light dots, multiple parallel light strips, geometric light grids. So, these are projected and then the details are collected. So, this is how it is. You see a DLP structure, light pattern generated. So, the light goes from here and then DLP is generated, then the object distorts the light pattern, okay, the object distorts the light pattern, and then the camera on the sensor detects the light, and then 4, the image processing and the triangulation algorithm determines the 3D structure of the object. So, this is how a structured light works for non-contact scanning. Moire fringe patterns or interferometer used for dimensional inspection and flats and deformation patterns, we use Moire fringe patterns. Michelson's interferometer, which is used to measure the angular displacements, we use it. So, that is what we are. Structured light pattern are projected on a surface to produce a shadow Moire effect. The light contour produced by Moire effect are captured in an image and analyzed to determine the distance between the light. The distance is proportional to the height of the surface at the point of interest. The Moire fringe technique accurately results for a 3D reconstruction and it gives you good results. This is a typical Moire fringe pattern. So, this is a typical Moire fringe pattern. You can see as and when I move, you see the patterns change. A Moire fringe pattern from a 2 sets of line which is angled at 5 degrees. This is a concentric circle pattern which is made. So, you can see that the concentric patterns keeps growing, and when you try to take the image of it, from the image you can try to correlate and try to find out the 3D object. We will next see the destructive methods of doing it. The destructive methods, here the RE destructive method is useful for small and complex objects with which both internal and external features can be scanned. So, what we are trying to do is we are trying to take an object, section the object and start doing it. A CNC milling machine exposes 2D cross section images which are then gathered by a CCD camera. Then the scanning software automatically converts the digital bitmap image to the edge detection image and forms a part. The model is remodeled and you get from slice by slice information. Here are the examples of 3D data application. Environmental data, GIS, air quality, water quality is taken for 3D data, building data, manufacturing data and medical data, all these things use 3D data application. Raw data components, there are raw data, textured, 2D image, spatial, n-dimensional image in terms of time and sensor data. So, you also have derived data, modeled data, technical data, and you have bookmark data. So, here are some of the data which are already available: traditional texture information, non-static information, 2D data, 3D data and multiple dimensional data. All these MET data are available and they are used as part of reverse engineering. So, to recap, what we saw in this particular lecture is what is reverse engineering, importance, process, what are the different types of scanners, what do you mean by point processing, what is geometrical model generation, what is the role of hardware and software, what do you mean by contact measurement and what do you mean by non-contact measurement or scanning. Okay. So, the task for the students is going to be watch YouTube for development of 3D scanners. So, here what they do is they use your camera what is used in your laptops, okay, and laptops for reverse engineering. So, what do? They take a camera and then they try to keep an object, then they try to keep the object in a frame, and in that frame they try to have reference points. These are reference points. This is the object. They try to calibrate with respect to the reference points, and then they try to go to the objects, scan the image of the object and try to get the data. Please watch that video and try to develop yourself a same technique. Use tennis ball as the object and try to do reverse engineering and see how do you get the data. Thank you very much.